Hello everyone, myself Vinay Kumaram. I am actually pursuing PhD in physics. So in this particular YouTube channel, you will be learning physics, chemistry and mathematics starting from 8th standard till 12th standard. So if you want to learn physics, chemistry and mathematics, then please do subscribe to my channel and stay tuned with my channel. So in my previous videos and in this video, I will be teaching the second chapter of 9th standard science subject. So that is matter around us pure. So in my previous video, I was actually explaining about concentrated solution, dilute solution, saturated solution, unsaturated solution, precipitate and more things about solution I was actually discussing. Even properties of solution was also discussed in my previous video. So in this particular video, I'll move on to the next concepts which are there in this particular second chapter of 9th standard science subject. So the next concept which you have after properties of solution is suspension. So what do you mean by suspension? As I explained in my previous video, a solution is a homogeneous mixture where solute is properly uniformly mixed with the solvent. That means solute has uniform composition with the solvent. So such kind of mixture was a homogeneous mixture and it was known as a solution. Here suspension means it is applied for a heterogeneous mixture where solid particles are mixed in a liquid. So let's say you have water in a particular container which is a liquid and you have some sand particles. So if you put this particular sand particles into this liquid, this particular sand particles will get suspended and settle at the bottom of this particular water. So that shows here sand is not homogeneously mixing with this particular water, but it is actually mixing as a heterogeneous mixture and it is actually getting settled at the bottom surface of the water. So that's why this is known as suspension. Because sand cannot homogeneously mix with water, they get suspended and settled at the bottom surface of the water. So here one important point which you should actually remember is that they get settled at the bottom surface of the liquid and they will be visible to the naked eye. If you take example of salt getting mixed with water, it is a homogeneous mixture. It is also known as a solution, salt solution. But there the particles, the solution particles, you cannot actually see through your naked eyes. You cannot find any salt particles visibly. But if you put sand inside water, you can clearly see the sand particles inside water. That means these particular particles are still maintaining the visibility. So through your naked eyes, you can easily notice the sand particles inside water. But in homogeneous solution, you cannot actually visibly see the solute particles because the diameter of that particular particles will be less than 1 nanometer. So that's why that will be not visible to your naked eyes. But in this case, in suspension, the solute particles will be visible to your naked eyes and they get settled in the liquid. So coming to the properties of suspension, similar to the properties of solution, you have opposite properties for suspension. So in properties of solution, you saw that the solution is homogeneous mixture. But here suspension will be heterogeneous mixture, because you might have a question where you have to give differences between solution and suspension. So solution will be a homogeneous mixture, but here suspension will be heterogeneous mixture. So in solution, particles, the solute particles will not be visible to your naked eyes, but in suspension, visibility will be there for solute particles. So solute particles will be visible to our naked eyes. So coming to the third property, in solution, the diameter of solute particles are very less, hence it cannot scatter the light rays. But here solute particles have bigger diameter. Because solute particles have bigger diameter in suspension, solute particles can scatter the ray of light, making its path visible. So solute particles can easily scatter ray of light and it can make the path of light visible in the liquid. And the fourth property of suspension is that particles get settled inside a suspension. So particles are solute particles, let's say sand in water, get settled at the bottom if they are undisturbed. That means if you do not disturb that particular suspension, then all the solute particles will slowly get settled to the bottom of that particular liquid. So this is actually the fourth point of suspension. So after suspension, you have one more concept, that is colloidal solution. Here, colloidal solution is also an heterogeneous mixture, but here in colloidal solution, the diameter of the solute particles will be lesser than the diameter of the solute particles in suspension. So here also colloidal solution is a heterogeneous mixture, but diameter is very small of these particular solute particles. Hence, they are dispersed uniformly throughout the solution. They are not dissolved in the solution, but they are dispersed uniformly throughout the solution. So if you are putting salt particles, if you are putting a salt crystal inside water, at that particular time, salt contains NaCl. This particular NaCl will be split into Na plus ions and Cl minus ions. So there is a kind of chemical interaction between NaCl and water. But in heterogeneous mixture, here also there will be uniform distribution of particles throughout the solution, but there will be no certain chemical interaction between solute and the solvent. So in heterogeneous mixture, there will be visible particles inside a liquid. So there will be visible particles inside liquid. Because there will be visible particles inside a liquid, so this particular visible particles can easily scatter light ray, and it can actually make the path of light ray visible inside the liquid. So they can easily scatter the light ray, and also it can make the path of light ray visible inside liquid. So this phenomena where scattering of light is taking place due to this visible particles in heterogeneous mixture. So this scattering of light ray makes the path of light ray visible, and this particular effect is actually known as Tyndall effect. So the path of light ray which is visible through the liquid is because the scattering of light which is taking place due to the visible particles which are present in that particular heterogeneous mixture. So let's say there is a ceiling on our head, and this particular ceiling, let's say there is a small hole in this particular ceiling. When the sun is shining bright, at that particular time you can see a small light ray which is coming through this particular hole from the ceiling, and you can clearly see dust particles through this light ray which is passing through this hole which is there in this particular ceiling. That means this particular dust particles or the smoke particles, so dust particles or the smoke which is there in the air will make light rays scatter, and this particular light ray will be visible when it is passing through the hole of a ceiling. So this effect is also known as Tyndall effect. So this occurs when there is a scattering of light due to some visible particles in a particular solvent, and they are actually responsible for scattering of light. So in this case, air acts as a solvent and the dust particles and smoke acts as solute. This particular distribution of dust particles and smoke in the air makes the light scatter and makes the path of light ray visible. So this effect is actually known as Tyndall effect. So now we will actually discuss what are all the properties of colloid. So colloid is also an heterogeneous mixture, and in colloid also individual particles cannot be seen through naked eyes. So individual particles cannot be seen through naked eyes. So what do you mean by individual particles cannot be seen? So there will be lot of particles which are actually contributing for the visibility of the solute inside a solvent. When you actually mix a particular solute which is uniformly dispersed but it is not homogeneously mixed, so there will be a heterogeneous mixture and there will be uniform distribution of particles. So particles in that particular colloidal solution are uniformly dispersed throughout the solvent, but they are not homogeneously mixed with that particular solvent. That means they have not formed uniform composition with the solvent, but they have uniformly dispersed throughout the solvent. So that's why in colloidal solution you cannot see individual particles, but group of particles will make difference. You can clearly see that particular solute has mixed in that particular solvent, but you cannot see the individual particles of that particular solute. But in suspension you can see the individual particles getting settled in the liquid, but in colloidal solution you cannot see the individual particles. So there will be a combined visibility of all the particles which are there in that particular colloidal solution. So this is one of the property of colloidal solution. So colloidal particles can scatter the light ray and makes the light ray visible. So this is actually the third property. And the fourth property is they do not get settled. Even though they are heterogeneous mixture, they do not get settled if they are undisturbed. Even when this particular solution is undisturbed, even when this particular colloidal solution is undisturbed, they do not get settled. That means the solute particles do not get settled in that particular solvent. So this doesn't prove that this is a homogeneous mixture. This is still a heterogeneous mixture. The only thing is diameter is little bit smaller than the suspension which we have discussed earlier. So that's why, because of smaller diameter, this particular solute particles will be uniformly dispersed, not dissolved. They are uniformly dispersed throughout the solution. Hence, in colloidal solution, you can find dispersion, uniform dispersion of solute particles throughout solvent, but they are still a heterogeneous mixture. Hence, because there is uniform distribution, uniform dispersion of particles throughout the solvent, even when the colloidal solution is not disturbed, still particles or the solute particles in that particular solvent do not get settled down. Hence, it is not known as suspension, it is known as colloidal solution. This is fourth property of colloidal solution. So coming to the fifth property, even colloidal particles cannot be separated through the process of filtration. So colloidal particles, since the diameter of this particular colloidal particles is very small, the pores of a filter paper. So in normal filtration process, if you take a filter paper, this particular filter paper will be having small pores which are having diameter in few microns. So there will be small pores in this particular filter paper where water and lesser diameter particles can easily pass through these pores. So even in colloidal solution, particles are very small in size. So solute particles, or you can call this as colloidal particles, which are actually dispersed in the solvent. These colloidal particles have diameter less than the diameter of the pores of this particular filter paper. So solute particles or the colloidal particles have diameter less than the diameter of pores which are present in this particular filter paper. Hence, these colloidal particles will easily get through that pores. You cannot actually separate out the colloidal particles using filter paper. So now you should actually remember the properties of solution and also properties of colloidal solution and also properties of suspension. So they might also ask the difference between all these three. So this is all there in this particular video. The next concepts which are there in this particular chapter I will be uploading in my next video. So if you want to learn physics, chemistry and mathematics like this starting from 8th standard till 12th standard, then you have to subscribe to my channel. Please do subscribe to my channel and stay tuned with my channel. Thank you.